Hey everybody, welcome back. And this is session 3 in chapter 1, States of the Matter. And in this session, we will learn how to get some measurements, how scientists use experiments to measure the melting point and the boiling point. The melting point is the temperature, if you remember, just to recap, the melting point is the temperature at which a solid substance is converted into liquid. And the boiling point is the temperature at which a liquid substance is converted into vapor or gas state. Okay, to know, if you ask yourself how scientists know that, for example, water, the boiling point for water is 100 degrees Celsius, and the freezing point of water is 0 degrees Celsius. The freezing point is the same as the melting point. How they know that? They know that by plotting what is called heating curve and cooling curve. And to do that, let's first know what is the heating curve and what is the cooling curve. The heating curve is a plot that represents the effect of slow temperature rising on a substance. So when temperature is raised gradually, what will happen to a solid substance? The cooling curve is a plot that represents what is the effect of slow temperature lowering on a liquid substance. For this experiment, to measure the melting point, we use this apparatus to record the heating curve, to record the rise in temperature and observe the effect of this rising on the state of the substance that we have. So we have some tools, which is, as you can see, a stand and a heat source, maybe a flame or any heating source, a beaker with a liquid. This liquid can be oil or water, and this depends on the solid to be measured. We have a thermometer, so it will be easy to report the rise in temperature, and a rubber band to hold the thermometer with the tube that contains the solid substance together, to fix them together, and a stirrer, and the heat is raised, and add the thermometer. After, we will prepare a stopwatch too, and every time you will record the change in temperature and the change of the state of the solid until the solid is completely converted into liquid. This is what happened. A capillary tube, we take some of the solid substance inside it and knock it twice or 3 times, so we make sure that all the solids are at the bottom of the tube. A thermometer. The capillary will be fixed together with the thermometer, and they will be placed in a beaker with a liquid. As well as I mentioned, the liquid can be water or oil. Okay, and then they are heated and stirred periodically to distribute the heat in the whole water bath or oil bath. Temperature will be recorded by using the thermometer every specific time using the stopwatch. So when the solid start to melt, the temperature will be recorded. And then when the solid is completely converted into liquid, the temperature will be recorded again. And we will use these recordings to plot what is called the heating curve. And from that heating curve, from that plot, we will get the melting point. So some notes to put into consideration for measuring the melting point. As I mentioned that the beaker will contain a liquid which can be water or oil. And choice of the water or oil is dependent on which substance is used to our measurement. So our standard is the boiling point of the water, which is 100 degrees Celsius. If the substance that we use has a boiling point less than the boiling point of the water, so water will be used in the beaker as a water bath. But if the substance has a boiling point which is more than or higher than the boiling point of the water, you will use an oil bath instead. Why do you think why we use water if the boiling point that, and we use oil bath if the boiling point is more than 100 degrees? You are excellent. What we need from this experiment is to convert the solid substance into a liquid by melting. Okay? And if the boiling point of the substance is less than the water, so the water, when we use the water bath and it will boil, it will reach 100 degrees Celsius, which is enough to melt the solid substance that we have to test. Okay, but if the solid substance has a melting point, has a boiling point that's more than 100 degrees, so water will boil at 100 degrees, and the substance will remain solid, will not melt, because the boiling point of the substance is more than that. It needs more temperature, more heat. Okay, so in that case, we use the oil bath because the oil boils at a temperature which is very high. So its boiling temperature will be enough to melt that solid substance. Scientists note that the melt, when the solid start to melt, the temperature remains the same until the whole amount of the solid is converted into liquid. And after the whole amount of the solid is converted into liquid, the temperature will rise again. And this is clear from the heating curve that we will see. What else? So we can continue using the same experiment to measure the boiling point. If we continue heating our solid until it completely evaporates. And in that case, if we use it to measure the boiling point, we will note that the temperature will remain the same from the beginning of the evaporation until the liquid completely evaporates. Cooling curve, which is opposite to heating curve. So we expect that here we will leave temperature to cool down. Okay, and when cold temperature, if a solid substance is melted, it will convert into liquid. And if it cool down again, it will return back to its original solid state. So for cooling curve, we use the same experiment, and we will use it to measure the heat energy required to return a matter from a state to another state. Why? Because cooling will will let the substance lose energy, lose heat energy. The heat will escape from our substance, which is heat energy. Experiment is the same, which is we use the same experiment that we do. We put a solid state, a solid substance in a tube and thermometer, a beaker with oil water bath, and then we will reach the melting point. Once the solid is completely melted, we will remove the heat source, okay, and we will put the thermometer inside the tube to measure the actual temperature of the substance, okay, and we will leave the substance to cool down again until it solidifies. And by using a stopwatch over the time, we will report the decrease in temperature during the conversion from liquid to solid. It's opposite to the heating curve, okay? So we will expect that the direction of the plot of heating curve is reverse to the plot of the cooling curve. So this is the cooling curve, okay? So we'll start with liquid state. We will allow it to cool down until it reaches solid state. When the substance, the liquid substance starts to solidify, the temperature will remain the same. It will remain the same until complete conversion into solid state again. Cooling curve is used to measure the heat energy or the energy that is released by cooling. Okay, so if we have substance E, which is solid, okay, which is solid state. Okay, this solid is converted to liquid by heating, by increasing the temperature, right? So when we heat a substance, we give this substance a heat energy. The particles gain energy. If you remember the particle theory, which is the particles are moving. And when we heat the particles, the movement is become faster and more rapidly. That's why, because the particles accept or absorb energy from the heat, from heating. Okay? And then it will be liquid. If we continue heating, this liquid will become gas, will evaporate. Why? Because this heat will give the particles more energy. And when the particles get more energy, they will move faster and the distance between particles will expand. So the liquid will convert into gas. If we allow it to cool down, so if we condense this gas, it will turn into liquid. Why? Because cooling down will allow the absorbed energy to be released, to lose the energy that the particles gain. Okay? And if we cool down again, the liquid will be converted to its original solid state. Why? Because the heat gained will be released or will be lost. So heating is giving an energy, cooling is taking an energy. So by conversion, solid to liquid, this is energy absorbed, heat energy absorbed. Converting liquid to gas, heat energy absorbed. Cooling down is energy release. So from gas to liquid, so energy will be released. From liquid to solid, another energy, heat energy, will be released. And the same for sublimation and deposition. From solid to gas, it is melting. So it's heating. So now it's energy gained. So C is energy gained or energy absorbed. While gas to liquid, it's cool down or freezing. So the gained heat energy will be lost. So here energy will be released. Okay.